Hi, my name is Patrick Reagan. Welcome to the Storage Devices series of videos where we can go in depth of the storage devices used in your computer, including hard drives, SSD drives, RAID, and removable storage. In Part 1 hard drives, it covers magnetic hard drives and the related form factors such as SATA 2.5 and 3.5 inch drives, disk performance, and disk reliability. For those who are going to take the A+ exam, there are practice questions at the end of the video. A computer drive is a hardware component that stores and retrieves digital data on a computer between your operating system, files, and applications. Drives are devices for long-term storage. In today's computer systems, primary storage can be found as hard drives, or HDDs, which are traditional storage devices that use spinning magnetic disks to store data. They are half mechanical, half electronic devices. They offer larger storage capacities at a lower cost but are generally slower than SSDs. Solid-state drives, or SSDs, use flash memory chips to store data, making them significantly faster and more durable than hard drives. They are ideal for users who prioritize speed and responsiveness. Other storage may include optical disk drives, USB or external drives, and network or cloud drives. Hard drives are non-volatile magnetic storage or disks that retain its content when there's no power. Older style hard drives are half electronic and half mechanical devices that use magnetic patterns to store information on rotating platters. Mechanical components limit access speed, consume more power than electronic equivalent, and produce more heat than electronic equivalent. Since these drives consist of mechanical parts, it is considered a high failure item because mechanical parts wear out faster than electronic components. Hard drives come in different physical sizes or form factors. 3.5-inch SATA hard drives are usually used for desktop and server components, while 2.5-inch SATA hard disks are usually used for portable or small computers. The hard drive is derived from the fact that the platters are solid. Platters are coated with magnetic material that can hold many tiny magnetic fields. The fields represent zeros and ones. The bits of information are written and read by the read-write head. The platters rapidly rotate around a spindle with speeds at 5,400, 7,200, 10,000, and 15,000 rotations per minute, or RPMs. A faster speed usually means the access time, which is the time it takes to find data, is faster. For example, a 7,200 RPM drive typically transfers data 33% faster than a 5,400 RPM drive. The read-write heads float on a cushion of air without touching the platter surface. The gap between the head and the disk is about 40 to 60 atoms high, or about 3 to 5 nanometers. The head actuator moves the read-write heads back and forth. The read-write heads use magnetism to write data by changing magnetic patterns on the drive and can detect magnetic fields on the disk to read the data. Platters are divided into concentric circles called tracks. Tracks are divided into sectors, whereas sectors are the smallest physical storage unit on the disk and on most file systems. Sectors are hardware-level units defined by the disk, which contains 512 bytes of usable data, with some newer drives using 4096 byte sectors. A cluster can consist of one or more consecutive sectors. It is the smallest amount an operating system can access. In a file allocation table, or FAT, each cluster is listed as a single entry, which indicates what file or part of the file is stored in the cluster. If the file spans multiple clusters, the cluster will also specify the cluster that holds the next part of the file. Unfortunately, if part of the file is stored in the cluster and the entire cluster is not used, the remaining part is wasted. By having a smaller list of clusters compared to a list of sectors, the operating system has reduced overhead in file system management because it has less entries to keep track of, improved read-write speeds because of the larger size of chunks that it gathered at once, minimized fragmentation so that files are not spread throughout the drive as much because of the larger cluster size, and optimized disk space usage for larger files. Zone bit recording, or ZBR, is the method used by disk drives to optimize the tracks for increased data capacity. It does this by placing more sectors per zone on outer tracks than inner tracks because the circumference of the outer rings are larger than the rings on the inner track. Access time is the average time it takes the read-write head to move to the requested sector, which is measured in milliseconds. Fast hard drives have a 5 to 10 millisecond access time, which is very slow compared to SSDs, which are 25 to 100 microseconds. Access time equals seek time plus latency time. Seek time is the average time it takes the read-write head to move to the requested track, and latency time, or rotational latency, is the time for the requested sector to spin underneath the read-write head. The disk transfer rate is the speed at which data is transferred to and from the platter. Hard drives can copy 30 to 150 megabytes per second, while a standard SSD can copy at least 500 megabytes per second, and some newer drives can transfer up to 3,500 megabytes per second. Hard drives have cache to boost performance by temporarily storing frequently accessed data. Since hard drives are relatively slow at reading and writing random data, a small amount of high-speed memory is built into the drive as a cache. It includes predictive caching, whereas the drive uses algorithms to anticipate which data will be needed next, storing it in advance for faster access. By using the cache, it minimizes wait time. Typical modern disk cache ranges from 8 megabytes to 256 megabytes, and some high-performance drives found in enterprise or NAS models may go up to 1 gigabyte. Mean time between failure is the average number of hours before a drive is likely to fail. Common MTBFs for hard drives is 200,000 to 1,200,000 hours, but may go higher. The higher the MTBF, the more reliable the drive is. You should expect a drive to last between 3 and 5 years. Question: why are hard drives considered a high failure item? Answer: because it is a half mechanical device. Question: today, what common device is used in computers to store data using magnetic patterns? Answer: hard drives. Question: what are the two sizes of a sector found on today's hard drives? Answer: 512 bytes or 4096 bytes. Question: what is the smallest physical storage unit on the disk? Answer: a sector. Question: what is the smallest physical storage unit on a disk seen by the operating system? Answer: a cluster. Question: what is the average time for the read-write head to move to the requested sector? Answer: access time. For more information, visit these sites. For long-term storage, computers use drives. Older style hard drives are half electronic and half mechanical devices that use magnetic patterns to store information on rotating platters. Since these drives consist of mechanical parts, it is considered a high failure item. Hard drives come in different physical sizes or form factors, including 3.5-inch and 2.5-inch SATA. Sectors are the smallest physical storage unit on the disk, usually consisting of 512 or 4096 bytes of usable data. A cluster can consist of one or more consecutive sectors and is the smallest amount an operating system can access. Access time equals seek time plus latency time. Thank you for watching this video. The next video will be Storage Devices, Part 2, SATA and SAS drives. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.